Hi, uh, this is a continuation of my previous video. Okay, Kira, I forgot to explain on the deep copy how the deletion was happening. So I will try to cover the deletion part as missed out in the previous topic. Okay, since the each member where each object has its own memory, like the OPJ2 till OPJ7. Each object is having its own memory. We can call delete pointer. Okay, we can call delete pointer. So this memory is not shared by other object. So each object member pointer has its own memory. So the deletion will not create any double free memory issue in deep copy. Okay, this topic was missed out in my previous video, so I have covered it here. Then we will see what is double free pointer and how it can be avoided. Okay, this is a sample program how the double free is happening now. So the source code can be located from this git repo link and the author name. And if you want to contact me, you can reach out through this mail idea, or you can add some comments. I will try to clarify your doubt, or I try to improve myself, or if I missed any special issue that could have been covered in this video, let me know so that I can cover it in my next video. Okay, here this is my class name and this is my number variable. This is a pointer. Okay, in constructor I'm trying to initialize it to null pointer. Okay, and in destructor I'm trying to see if it is not a null pointer and I'm trying to delete it. Okay, you see, in a constructor will be called when we try to create an object. So in the default constructor, I initialize the pointer to be a null pointer, which is a good practice to initialize it. And in the case of destructor, I will be checking whether the pointer is not null pointer. Then I will try to delete it. Okay, and then after deleting, I will try to initialize it to a null pointer. After deleting it, I am marking the pointer to be a null pointer, and then this destructor will be called when the object goes out of scope. In the case of set data, this is a setter function. I will be getting a value from a main program, and if the memory pointer is null, then I will create a memory for the pointer and assign that value to the pointer. If the memory is already there, I will try to assign that value to the address which is already pointed by this pointer. Okay, in get data, I will try to print the address and the content value. And this program is to explain how the double free is happening in the case of shallow copy. Here only the class is having only one memory variable, and I'm creating a memory for that pointer and then assigning a value. The memory is not null only, I'm assigning creating a memory. If it is already there, then I will assign directly the content. And then during a destructor, I'm trying to delete that memory. If it is there, then I'm trying to delete it. Okay. Here I'm trying to I have created an object. So default constructor will be called and the pointer will be pointing to a null pointer, and then set data will call the setter function. The value 30 will be passed over here, and the pointer is null. So since it is we are passing a null in the beginning, initialized to null. Here the pointer will be null, and I have allocated a new memory and then assign that 30 to this new memory. Okay. Now L object 1 memory pointer will have the content 30. Correct, huh? Okay. So this is the address of the memory and then content 30 is pointing over there. Now the double free, I have created another object and I am doing a copy. I am using a default copy constructor. So the obj1 will be copied to obj2. Obj2 memory pointer will also point to this address. Since it is using a default copy constructor, but the content will be changed to 130. Since we are checking if the memory is already there, we are only changing the content. Okay. Now we have changed the content. If we print the content, both obj1 and obj2 will point to 130. Since since it is having sharing the same memory. Okay. Now when this when this when the program is about to exceed, then delete will be the destructor will be called. What we have done, we are trying to free the memory. If the memory is if the memory is not available, if the memory is not a null pointer, then we are trying to delete. But remember, in shallow copy, the member variables are same, but the content might be the content also will be the same. The memory pointer is pointing to the same memory address. Okay. So what happens when the obj1 is going to be destroyed? So we have created three objects. So when the first object is going to be destroyed, the delete will be called first. So memory will be freed, but the second object pointer will also refers to the same memory. Okay. Second object and second object pointer is also referring to the same memory, so the pointer will not be a null pointer, so it will try to delete a memory which is already freed by the previous object. So we will lead to a double free. You see here we have created a three object, okay, obj1, obj2, obj3, but after calling second, the double free has the segmentation fault has happened. So it will come here for the relation of the second object. Since the memory is already freed, it will say double free and the segmentation fault only happening. The third object, it won't call the destructor because by the time the segmentation fault is happening. This is how the double free problem is happening in shallow copy. Okay, in shallow copy, since the memory is pointed, same memory is referred by several member variable. Uh, Deleting, if any one of the object is deleting the memory, the other object is also will also try to delete the same memory, which could lead to the double free problem. Okay, how this problem could have been avoided? There are multiple ways that the problem can be avoided, but we will try to see uh, the two easiest way. Okay. Okay. First one. Okay. This is where we are going to create a reference counter, so that we will come to know how many objects are referring to the same memory. Okay. This is what we have done. We have created a reference counter. The reference count will be incremented by 1 if the memory is pointed by the other object. Is also referring to the is also referred by other object. Okay, we will go through the example. Okay, avoid double sweep issue. Here is the same pointer. Here we have created a static number variable. Why we created a static number variable? This count has to be common for all the object. Okay, this count will be incremented when the memory is referred by the multiple other object. Okay. Now, in the case of a constructor, I have created it to a null pointer, initialized it to a null pointer. In the double free, okay, in the okay, and This is a sample example only. What I have done, I have called it double tree copy constructor where I have incremented the reference counter when we are trying to when the second object is referring to the memory allocated by the previous object. Okay, so after assigning the previous assigning the memory address, I have incremented the counter. The same could have been done in the assignment operator also. So when I try to uh, assign the counter memory address to this pointer, I have incremented this counter. Okay, and in the destructor, I will check whether the counter value is 0. Only if it is 0, I will be deleting it. If it is 0, okay. If it is 0, then I will check whether it is a not null pointer, and if it is not null pointer, I will delete it. Else, if it is not 0, I will not delete the memory because some other object is referring to the same memory. I will decrement the counter alone. Okay. I will go through the example. In the set data, here I am allocating a memory uh, and I am assigning the value to the new memory. If the memory is already assigned up, is already created, I will try to change the content value of that memory alone. This is a getter function where I will print the address and uh, content value. Here, this is a definition how to define the static member variable. Okay, the static member variable, I am trying to initialize it to 0. I will go through one more time by diagram. Here, what I have done, I have created an object. Okay, star ptr. Have another object which is also holding a star ptr. Okay, now I have created a memory. This pointer one of the object one is referring to this memory, which is starting address is 1000. Okay. Now, by in the copy construct in the shallow copy, we will be copying. We will refer to the same content. Okay. For the first case, here the reference count value will be incremented to 1. Okay. And when another object, okay, another object is also referring to the same memory, then in the reference count value will be 2. Okay. When it is trying to go out of scope, then we are trying to decrement the reference count to 1, and we will check whether the reference count value is 0, then only we will delete it. So when this object goes out of scope, reference count value will be reduced to 1, and when this object goes out of scope, reference count value will be 0, and when this object goes out of scope, during that time the reference country value, since it is 0, we will delete the entire memory. So only one time we are deleting the memory, not multiple times. Okay. Here how this memory is allocated. Here avoid the double. This is a member variable, and I am declaring it as a null pointer. I have used a static count. The static count is to monitor how many objects are sharing the memory, same memory. Okay. So how the memory could have been shared? It could have been shared in the copy constructor or in a overloading assignment operator. So we have overloaded the copy constructor and overloaded the assignment operator, and we have assigned the same memory to this current object memory and incremented the counter. Okay. Similarly, in the case of assignment operator, we have assigned the previous object memory address to the current pointer. Here, if you print the address, okay, address of this object, each each object member will have a different address, but the value remains the same. Here the pointer of object 2 and the pointer of object 1 will be different, but this content, right, is the same. Okay. So here after assigning the memory address to this pointer, we are incrementing the counter. Similarly, here also we are incrementing the counter. When during a destructor, we will check whether it is equal to zero. If it is equal to zero, we will delete the memory. When the object two goes also out of when object three goes out of scope, then here it is uh, not 0 because it is count 2, then it will be reduced to 1. When object 1 2 goes out of scope, then it will come here, it will check since it is 1, it will reduce to 0. When object 1 goes out of scope, it will be 0 and it will go inside the pointer value is not null, it will delete and it will be exceeding them. Okay, this is how we can avoid a double sweep problem by adding a reference to it. Here we have created our own reference. Okay, by declaring a static pointer. This is necessary? No, this is not necessary. We have already a shared memory concept which will take care of the reference counter. Okay, how to do this? Here this is a shared memory. We will add a different video on how to use the shared memory. I'm trying to tell there is a different way to implement the reference counter. So I'm trying to show the program to avoid the double field problem caused by shallow copy, how it can be avoided by the SAT memory. Okay, in order to understand this double field problem, right, you need to go through my previous video on shallow copy versus deep copy. Okay, without going through the video, don't directly jump into the second video. Okay. Now, how can I avoid the double field problem? Here I have declared a start pointer. Okay, this is a declaration. Here we have to include a memory header and we have declared a start pointer. This is a here how we can declare a start pointer. Okay, here initializing it to a null pointer, and then in the case of double tree, right? In the case of a destructor, I am trying to so it is a not null pointer, and I am trying to this is also not needed. Okay, let it be. Okay, not null pointer. Definitely, it won't be a null pointer. Okay, because we have assigned some value. Okay, let it be. If it is a not null pointer, then I am trying to see print the use count value. Okay, the use count value will be 1 at least if one the memory allocated right here. Same way. Here the reference count. Here the reference count will be 1. Here the reference count will be 2. And the reference count will be 3. Okay, when the memory is allocated and someone is referring to that memory, then the shared pointer will have a use count of 1. If the other object is referring to the same memory, then the reference count will be 2. When the object 3 is, if it is referring to the same memory, then the reference count will be 3. We need not delete the shared memory when the object is going out of scope and the reference count is 0, then the shared memory will delete the allocated memory. That is so that there won't be any memory leak. In the case of if we are allocating a memory using new, then it is our responsibility to delete it. But in the case of shared memory, if the object goes out of scope, then the memory will be freed by the shared pointer. we need not take care of deleting it. What I have done here in the destructor, I'm trying to print how many object is referring to this shared allocated memory. Yeah. This use count will give a use count will give the use count will give the reference counter. Okay, in the set data, if the pointer is null, then I am trying to allocate a new memory, and then I am assigning that value to that shared memory. Okay, there are different ways how to check a null pointer. Okay, I can put a shared pointer equal to null pointer. Then it means I am trying to check whether the null pointer is empty or not. There is another way, dot get equal to null pointer, to check whether it is a null pointer or not. Similarly, uh, pointer dot reset a new int. This way we can initialize we can allocate a memory and initialize the new memory to the value. Allocate a new memory and assign the memory with this value passed from the main function. Or you can use make shared, and then this is the another way of initializing it. Okay, two different ways of initializing a shared memory. The memory is already there, then we can directly assign the value to the shared memory like this. Here in the getter function, we are trying to print the address and the value to it. Here I have created a object, so default constructor will be called, and I'm going to create a shared memory and assign the value 30 to it, and then I have created another object. I have created another object, and then I'm trying to call a copy constructor so that the content from this object will be copied to obj2. But here, since it is a even though it is going to call the default copy constructor, since it is a shared memory, right? When the PTR of this object is going to refer to the memory allocated by the PTR of OPJ1, the reference count will be incremented to 2 in the case of OPJ2. Okay. And similarly, even though if it is assignment operator, if you are going to call the default assignment operator, since it is a shared memory, here the reference count is also going to be changed to 3. Okay. Now the reference count is 3, 2, 1. Okay. And you see the address is going to be the same. Here the use count is 1, use count will be 2 in this line, and use count will be 3. Similarly, in the case of a destructor, when the object is trying to go out of scope, we will have 3, use count will be 3, and then 2, 1, and then finally the object will be, the memory will be deleted. So the double free problem will not be happening. Okay. Here what we need to know, right? We need to know how to use the shared memory. Here include a memory for using a shared memory unique pointer, or we need to use this header file, and then here shared pointer int. This is a way to declare a shared pointer, and then this is a way to check whether the shared pointer is null or not. And then if you want to create a new memory, there are two ways. These are the two ways to create a new memory to it. And then when even though in the shallow copy we are copying default copy constructor and default assignment operator is called, the reference count is incremented for each object. So when the object is going to be deleted, the reference count will be incremented one by one, and when the reference count is 0, then that time only the memory will be freed. So the double free problem won't happen in the case of shallow copy if you are using the pointer to be a shared memory. Thanks for watching this video. If you have any doubts or questions, please feel free to add it in my comment section. Th- Thank you. I will add my next video and will update you. In the meanwhile, if you want me to cover any special topic, then you can add it in the comment section. I will try to cover it up.